Okay, I want you to picture a scenario for a second. It's a little bit absurd, but just stay with me.
All right, I'm listening.
You're planning an expedition, a huge one, into like a dense, uncharted jungle. You spend millions of dollars on it.
Okay.
You hire the best cartographers, the most rugged explorers, and you spend, say, 6 months just hacking through vines to build this perfect high-res map of the whole terrain.
Right. A massive investment.
You finally get from point A to point B, mission accomplished. And then, the moment you arrive, you light a match and you burn the map.
That sounds like madness.
Yeah.
I mean, you're literally destroying the only record of how you even survived the trip.
It gets worse. 2 years later, your boss comes in and says, hey, we need to go back into that jungle, and what do?
Let me guess. You start all over again?
You hire new explorers, spend another $1 million, and start hacking through the exact same vines.
Theoretically, no rational business would ever operate that way.
Oh,
It's insane.
theoretically, sure, but practically. According to the deep dive we're doing today, this is pretty much standard operating procedure for almost every major company on the planet.
So we're talking about legacy modernization.
Exactly. Companies spend absolute fortunes analyzing their old systems just to move them to the cloud or a new platform, and then once the project is over, all that intelligence, it just, poof, it evaporates.
It is the great paradox, isn't it? We've got companies that track every single click a customer makes down to the millisecond.
Right.
But when it comes to their own internal systems, the engines actually keeping the business running, they often have no idea how they really work.
And that's our topic for today. We're breaking down a really fascinating article from Code Aura. It's titled, From Modernization Projects to Modernization Products, Why System Intelligence is Becoming a Reusable Asset.
A very timely topic.
It is, but I have to play devil's advocate right out of the gate here. Surely CTOs aren't just burning the map for fun. Is it really that wasteful, or is the source material being a little bit dramatic?
No, it's not dramatic at all. It's actually, it's structural. The waste is built into the business model of how IT has been done for 30, 40 years.
Okay.
And that's what we need to unpack. The mission for this deep dive is to figure out why we treat all this system knowledge as, disposable trash.
And what happens when you flip that script?
Exactly.
Yeah.
What happens technically and financially when you start treating it like a permanent asset?
So let's start with the status quo. The article calls it the Groundhog Day of modernization. I'm assuming that's a reference to the Bill Murray movie.
Precisely. You're reliving the same day over and over. Think about how a typical modernization project kicks off.
Okay.
You have some massive monolithic system. Maybe it's 30-year-old COBOL code on a mainframe, or, a sprawling Java thing from the early 2000s. And management decides, we have to move this to the cloud.
So they treat it like a project, start date, end date, budget.
And that is the first fatal flaw. It's this project-centric mindset. To get it done, they mobilize an army. They bring in outside consultants. They pull their best internal engineers off other important work.
And they start the discovery phase, which is basically just archaeology, right?
It is. They're digging through layers of code sediment. They're reading it line by line, trying to figure out data lineage, business rules, all the hard-coded dependencies.
And they're producing tons of documentation.
Oh, massive amounts. Word docs, Visio diagrams, Excel sheets tracking IP addresses, the whole 9 yards.
And this usually works, right? They eventually move the system.
Usually, yes. But here's the catch. Success is measured by the cutover.
Did it turn on?
Exactly.
Yeah.
Did the system turn on in the new environment? Is it stable? Did we stop paying the old data center fees? If the answer is yes, the project is declared a success.
And the team disbands.
The team disbands. The consultants go to their next client, and that huge pile of documentation, it gets filed away on a SharePoint drive that, let's be honest, nobody ever opens again.
So the map isn't literally burned, it's just archived into oblivion.
Which is effectively the same thing.
Yeah.
Because the moment that system changes, and systems change constantly, that static documentation is obsolete. It's dead.
So when you need to integrate a new app 3 years later,
You have to start the discovery process from near zero. You can't trust the old docs.
this brings up the human factor that the article talks about, the SME bottleneck.
Ah, yes.
I feel like every company has that one person, let's call him Bob, who's the only one who knows how the billing logic actually works.
The Bob factor is a massive, massive risk. In this project-centric model, knowledge is stored in two places: static PDFs that nobody reads, and what the article calls tribal memory,
Which is Bob's brain.
which is Bob's brain. And when you rely on tribal memory, you are one retirement party away from a complete catastrophe.
Or one lottery win. If Bob wins the Powerball, your billing system is just a black box.
And it's even hard on the big partners, the system integrators who do this work. You'd think they'd love the billable hours of rediscovering the same system twice.
You would, yeah.
But the article points out it actually kills their margins. Their senior architects get stuck doing this repetitive, boring analysis instead of building new, high-value solutions for their clients.
Okay, so the process is inefficient, I get that. But let's talk hard numbers. The article lists some hidden costs. Which one of these really hurts the bottom line the most?
It has to be the cost of knowledge recreation. I mean, the source estimates that in large enterprises, you are looking at tens of thousands of hours.
Wait, tens of thousands?
Tens of thousands of hours of senior engineering time, just spent relearning things that were already known a few years ago.
That's staggering. And think about the opportunity cost.
That's the key. It's time not spent building new features. It's not spent on innovation. It is work that produces, and I'm quoting here, no net new business value.
You're just paying a premium to get back to the starting line.
Exactly.
Okay, the article also mentions delivery drag. Is this just a fancy term for everything moves slowly?
It's a bit more specific than that. Think of it like this. When a new team inherits a modernized system, but they don't have the deep behavioral context of why it was built that way, they become paralyzed.
They don't know where the landmines are buried.
Precisely.
Mm-hmm.
So they code defensively. They add wrappers around things instead of actually refactoring them. Velocity just plummets.
So what was supposed to be a modern, agile system
Immediately starts accumulating new technical debt.
Yeah.
Because the operators don't have the confidence to drive it fast. It's like renovating a building after you've lost the blueprints to the electrical wiring.
You can paint the walls, but you're terrified to drill a hole.
Because you might hit a live wire.
Yes. And then there's the audit nightmare. This one really felt visceral to me. If I'm a bank and the regulators come knocking on Monday, how does this project mode fail me?
In a regulated industry, you have to prove with hard evidence how your data moves. Show me every system that touches a European citizen's credit card number.
A question you have to be able to answer.
And if your knowledge is trapped in Bob's head or a 3-year-old diagram, you simply can't answer that question.
So you panic.
You trigger what's called a manual reconstruction exercise. You pull 20 engineers off their real jobs and make them read code for a week straight just to trace the data flow for the auditor.
It sounds expensive, stressful.
And it's incredibly prone to human error.
Okay, so we've established that the current way of doing things is wasteful, it's risky, and it relies way too much on Bob.
Right.
The article proposes a solution: system intelligence. Now, I have to be the skeptic. Is this just a buzzword? Is this just, better documentation 2.0?
And that is the crucial distinction to make. The author is very clear that system intelligence is not documentation.
Okay.
Documentation is static text.
Oh.
It describes what you hope the system does.
Mm-hmm.
System intelligence is a dynamic, machine-readable model of what the system actually does in production.
Okay, so strip away the marketing speak. Technically, what is it? If I look under the hood of system intelligence, what am I looking at?
You're probably looking at something like a graph database. Imagine a massive network map where every single node is a piece of your code, a function, a database table, a variable, an API endpoint.
And the lines connecting them.
Represent the actual execution flow, the data dependencies.
So instead of a paragraph of text saying the billing module talks to the shipping module, you have a queryable data link between the specific lines of code that do that.
Correct. It captures the behavior. It processes the code itself to understand the control logic, the exception paths, the data transformations. And because it's data, you can query it.
So I could ask the system, show me every function that modifies the account balance field.
And it would generate an instant accurate map for you.
That's the machine-readable part. But the article really emphasizes that it has to be living. How do you keep this from becoming just another stale map like the PDF?
You integrate it directly into the pipeline. This is the big technical leap.
Mm.
In a modern DevOps setup, every time a developer commits new code, the system intelligence platform rescans that chain.
It updates the graph automatically.
Automatically. So the map redraws itself every single time the territory changes.
Wow.
So if an auditor walks in on Monday, you don't call Bob. You just query the current state of the system and get a verifiable answer instantly.
That fundamentally changes the scaffolding metaphor the article uses.
It completely flips it. Right now, we treat assessment tools like scaffolding. We put them up to fix the building, and then we tear them down.
Right.
System intelligence is like installing a permanent smart home system into the walls. It stays there, monitoring the health and flow of the house forever.
Okay, let's talk about reusability. The title of the article is From Modernization Projects to Modernization Products. How does owning this intelligence actually change the work of engineering?
It creates compounding value. Let's say you do a project today to migrate your database. You build this system intelligence map to do it safely.
Okay.
6 months from now, you want to build a new mobile app that needs to pull data from that same system.
In the old world, you'd start from scratch, digging all over again.
In this new world, you use the same map. You can instantly see the right API endpoints, the data structures, the logic. You're not reconstructing context, you're extending the platform.
This has to be a game changer for the system integrators, for the partners, but I mean, doesn't this hurt their business model? If they charge by the hour, don't they want the chaos?
That's the cynical view, and, historically maybe there's some truth to that, but the market is shifting.
How so?
That body shop work, just throwing bodies at a migration, is becoming a race to the bottom on price. The partners who are going to survive will be the ones who sell outcomes.
So they offer a premium service?
A premium service. A partner can now say, we will migrate you faster because we bring this intelligence platform and we leave it with you so you're safer afterwards.
They stop being just movers and they start being architects.
Exactly. They move from a transactional relationship to a truly strategic one.
I want to pivot a bit to the learner aspect here. We have a lot of listeners who are early or mid-career engineers. The article talks about a staffing revolution. How does having a system intelligence layer change my life if I'm a developer?
This is huge for the talent shortage. Right now, to work in a complex legacy system, you basically need to be a wizard.
You need 20 years of context to not break things.
Exactly. And that makes it very, very hard for junior or mid-level developers to contribute meaningfully.
Nobody wants to touch the spaghetti code because they're afraid they'll take down the whole website.
But if you have an intelligence layer, a map that warns you, hey, if you change this variable, you're going to break the reporting module, suddenly a mid-level engineer can work safely in that environment.
It lowers the barrier to entry for working on these complex systems.
It democratizes the knowledge. You don't need to hunt down the one gray-bearded wizard in the basement anymore.
The knowledge is right there on the screen.
It is. And for a younger developer, that means less time acting like a digital archaeologist, digging through dusty old code, and more time actually building cool features.
Which is what everyone actually wants to do. I mean, nobody goes to a coding boot camp dreaming of reading 30-year-old documentation.
And it helps solve the COBOL crisis, right? You don't necessarily need to teach everyone COBOL if the system intelligence layer can interpret the logic for them and expose it in a way they can understand.
So looking forward, the article talks about this being the end of the Big Bang modernization.
This is really the destination. Continuous modernization. Instead of saving up all your changes for one massive, terrifying project every 5 years.
The lift and shift nightmare.
You move to a model where you're constantly refactoring, constantly upgrading, but in small, safe increments.
And you can only do that if you have visibility.
You can only do that if you have a persistent control plane, which is this system intelligence, giving you that visibility across the entire stack.
It's like the difference between driving a car with a really dirty windshield where you have to stop every 10 miles to wipe it off, versus driving with a heads-up display that shows you the road in real time.
A perfect analogy.
Yeah.
And that leads to what the article calls compliance as a state. You aren't getting ready for an audit. You are always ready.
Compliance is just a query you run.
You're not a project you staff.
So we're really shifting the economics from paying for labor to investing in assets.
That is the perfect summary. Code is cheap. Generative AI is making code even cheaper. The asset of the future isn't the syntax. It's the understanding of how the system fulfills the business intent.
And if you treat that understanding as disposable,
You are throwing away the most valuable thing you own.
it's a really compelling argument. We spend so much time obsessing over the new cloud provider, the new language, the new framework, but we spend almost no time preserving the why.
And as systems get more and more complex, the why becomes the only thing that keeps you from collapsing under your own weight.
So here's the thought I want to leave everyone with. If your organization is ramping up for a modernization project right now, or maybe you're in the middle of one, ask yourself a really hard question.
Okay?
Are you building a map that you actually get to keep? Or are you just renting a tour guide who's going to show you around for 6 months and then leave with all the secrets?
If you're paying for the discovery, you should make sure you own the result.
That's it for this deep dive into system intelligence. Thanks for listening, and we'll catch you on the next one.
Goodbye, everyone.